Can Zig outperform Rust, or vice versa? Which is really the true champion closer to the metal? We'll find out. Well, sort of. So I won't waste my time with this, but this is a companion video to the Zig versus Rust mainline video I did. This is just going to be a live-ish demo. So this is going to be mostly unscripted, lightly edited stuff. So anyway, not to waste time, we have both of these essentially coded to do the same thing and have the same app. So both of these are command line apps that take in a file that has words. Like here's one that's just a bunch of just gibberish for words, and then we also have Moby Dick here, and these take in those files, read all the words, and gives you the word count. These are very, very simple apps, right? These are just very simple command line apps. They're not a serious like enterprise app or like a really intense networking related app, but I think it should give you a sense of the performance of these, at least, and what they look like when you code it for the same thing. And you also, I mentioned performance because this does give you the elapsed time in nanoseconds and milliseconds for both. So we get to see that, which is good. So let's break these down. So first and foremost, you'll notice that, let's at a high level, these do look a little different, right? And let me expand this so you get to see it, see more of it. That should do. So they do look a little bit different. For me, both are readable. They're not that crazy. If I had to give my opinion right now, which one I think looks nicer, I probably give it to Zig. Even though I learned, and I put that in quotes, learned, I'm not a serious Rust developer, but I did look at it and play with it before I touched Zig. As I say that as someone who looked at Rust before Zig, that Zig does look kind of nicer to me. Just something's more elegant about it, if I had to say it. That said, not everyone agrees. I've seen a lot of comments saying that, oh, I don't like the Zig syntax. I think it's too clunky. I like Rust's. And it's pretty much pure opinion, pure taste. It kind of really depends on what you like. I will say, as far as the number of lines for these, this one's 60, and this one is 49. So that bit of abstraction. As the video said, this this abstracts a lot more, so that's probably a good explanation of why this is slightly shorter. But this is not too crazy long. It's not like when I showed you a C and a Zig example, right? There was a pretty big difference there in some cases. So yeah, as far as pulling in the libraries, these are essentially, even though this looks like it's pulling in more than Zig, they're both essentially just pulling standard library stuff. It's just pulling in differently. So this one pulls in just the standard library as a constant, and then calls its particular packages, whatever the Zig terminology is, right? I'll say it's package, and then it pulls in like the given package in the standard library, right? And then calls a method or function. It does that throughout here. And this one just pulls in exactly what it needs. Like, oh, I need the end package, I need the file, public struct, I need the buff reader, I need the read, and then it uses that and calls any methods related to that. So they're essentially doing the same thing, just in slightly different ways. The one thing I would say that's kind of nicer about Rust is that when I was calculating the time that it was elapsed, Rust has a nicer way, I would say, of calculating the nanoseconds and milliseconds. So for this, I did, just full disclosure, I did have AI help me generate this. And Zig, I will say, I think somebody mentioned something about vibe coding. I will say Zig is harder. This this session kind of reminded me of that when I had AI generate this stuff, it got a lot wrong for Zig, whereas for Rust, I think it pretty much one-shotted. It was very easy for it. But for Zig, it messed up because it was looking at an older version, and it should have looked at, I think we're on Zig 15 right now. So, and because of that, it tried to use, I think in part, it tried to use a function that did not exist. So the only way it could really calculate the milliseconds, it automatically, when you get the time, it's in nanoseconds. But to calculate the milliseconds, you had to take the nanoseconds and divide it by this nanoseconds per milliseconds variable. It's just a little helper to help you calculate. So you divide that and you get your milliseconds. So that's not a big deal. But it's a little nicer in Rust, is that once you get the elapsed time, right, it's the same thing as the timer.read here. Once you get the elapsed time, you can say as nanoseconds and as milliseconds, and you easily get the nanoseconds and milliseconds that way. So that's a somewhat nicer element of Rust. And again, I would say there are things in here that do show this is a somewhat more mature language than Zig, though not by much. You can do a lot of the same stuff in Zig in this example, at least, that Rust does, and that's probably in part because it's a very simple example of getting the time, getting a file. You know, it's pretty simple. But that is one case I would say where it's a little more mature. Anyway, I'm making a big deal of it, but when it's not that big of a deal, but it's a nicety that I think, gives a point to Rust. All right, the other thing is the memory management, as that video mentioned, the mainline video mentioned. We use allocators to manually manage that memory. So you see that we get an allocator here, and then use that to get our argument. So this is an argument allocator, right? So this is a command line app. So this is what pulls in the command line argument. So it uses an allocator for that. And then, once we get that, we free up the memory there. So we defer and then free it once it's used. So, right, so it's manually managing that. And of course, have the buffer here to read in the file, which this is also something Rust has. But what Rust does not do, right, by default, when you're not in unsafe mode, it does not have to manually manage memory. Instead, it's using that borrow checker to manage it, which in a more complex app can be a pain. But in this example, it is nice that you don't really have to worry about that. Right? You just get your stuff, pass it around where you need it, and you're good to go. So it's not that, in this simple example, the borrow checker, I would say, wins out because you don't have to worry about memory. But in more complex programs than this, you're going to start seeing some pain points when you have to struggle with the borrow checker. Whereas this can be its own pain point, probably less so than C, but this is its own pain point of having to deal with an allocator and having to manage it. But at least you can kind of tell, where you create your allocator, where you free your memory, that sort of thing. So that's a big difference. And then otherwise, it's very, very similar. As I said, like, both are getting the command line arguments in their own idiomatic way right here. Both are reading, opening a file and then reading it, very similar. Both have a loop, and again, doing it in their own idiomatic way. This one is actually a dedicated indefinite loop. That's nice. Whereas you have to do a while true. That's not unusual. That's very basic and common in a lot of other programming languages. So both do an infinite loop and break out of it once you hit a certain condition. And then, of course, this is the counting process, a little more verbose. Though I think Rust, that's probably in part because Rust takes a few shortcuts here that this doesn't. But it's doing the same thing, checking like, hey, is there white space? If so, hey, this is if it is white space, it's not a word, and else. Essentially, anything that's not white space is a word, essentially. And this has the same logic, and they both have the nice, is this white space method helper for this, which is nice. So they're both mature enough. Zig is mature enough to match that with Rust. And again, we have the timer, which both start at towards the beginning, of course, which that would make sense. Right around here, both start the timer here, and then end it right here. So very similar. And again, we already talked about the calculation difference here. And of course, they have their own idiomatic way of printing. Another thing that's kind of interesting to note is while this is just, plain old void main function, very common in all the programming languages, this one returns a result. This is specific to I/O operations. So instead of just returning void, this can return at the end, like after everything is done, it can say, okay, right? The result is okay. So that's kind of nice if you're dealing with I/O operations and you want to make sure the process ended appropriately. Of course, that's what errors are for as well, but this is nice. Yeah, error handling. This returns an invalid arguments if you don't have the right arguments. This has a matcher, essentially, or I guess you call it an option apparently in Rust. Just saying, hey, if there's no arguments, hey, return this exit code, print out this error here, right? So same thing, just different idioms. All right, so that's pretty much it, I would say, as far as file contents and what they do, how they differ. Let's actually get to running them. So let's start with I'll start with Rust. So we're using, actually before that, let's look at their package management systems. So let me go open the build Zig and let me open the cargo. Great. So you can see one's a lot bigger than the other. As mentioned in the video, cargo's package management system is so much more mature, and this one's also much more concise. Just name your package version, the addition of the toml you're running, and then any dependencies. We have 0 dependencies here. And this one, to just get started with something like this, you need to do all of this stuff. You need to set the target options and the optimize options, which we're just using the standard. We gotta add our executable. Point to the file that we're going to compile and then create the executable for. You install that artifact. You add the run artifact. You add steps. You got to do all that before you can even build it and then run it. So that's, I would say the good news about this is you get a lot of control. It's in Zig. If you're very comfortable in Zig, you can program this, in a very detailed way, but it's not if you don't want to have that much customization. You just want a simple package manager. This is a lot better, I would say, and a lot more mature. But both work. So for example, if we're going to run it, so with this one you can just do a cargo run, which will build it and run the program. So we can do a cargo run as long as we're in the same folder, which we are, as our cargo file there. So we can do I am showing you an example of the error. That's an error we get if we don't add the file. So I'm not gonna do Moby Dick yet. Or .txt. Yeah, there you go. So 11 words and 8,337 nanoseconds or 0 milliseconds. It's too few words to really even have any milliseconds. We'll get to that later. For this one, you would do, so there is a slight bug, and maybe I didn't have the time to really debug it, but one unfortunate error it has, I can't do the same thing in this. So I can't say zig build run. You can usually do a zig build run if we don't have any command line arguments, but if I do a zig build run And then let's use the word text because I also have that. Let's see if I could spell word text. Yeah, this one doesn't like it because it complains like, hey, there's no step name word.text. So when we set up our step here, right? So it's setting up a run step to run the CLI, right? So I would say this is probably a bug and you probably can fix it. But because of that, I can't just simply run it kind of like the cargo. So that is something, again, I would give a point to Rust because that makes it a lot simpler. You don't have to deal with that. You can just pass that command line argument and it works. This one, you can't really do that with this. So instead, for us, all we can do is do zig build. Okay, that's good. And then go to zig out bin and then the word counter, then the word text, which is not a big deal, right? This is not too crazy. But this is what this does. So yeah, so this is how's elapsed in 24,764 nanoseconds. You're getting a hint of some time differences here. We'll come back to that. Anyway, so that's how you would run it, which that's no biggie, but I would say a little simpler with Rust, but you do get a lot more customization with this build.zig. So anyway, let's get to the main, what I would say the more interesting and exciting show, reading Moby Dick. So these files I took from Project Gutenberg. I took a text file with the entire Moby Dick story, which is, I'm not going to tell you how many words yet, but it is I can tell you it's 22,308 lines. Of course, that includes stuff from Project Gutenberg itself, but still, right? It's a big book. So let's see, starting with Rust, how many words it calculates and how fast it is. So cargo run, and we're going to do that. Okay, so here's what we have. So it has 215,840 words, which I double checked. This is in the ballpark of how many words Moby Dick has, and it took 12 milliseconds, approximately, as it says, approximately 12 milliseconds. So okay, that sounds fine. It was pretty fast, as you saw. And of course, as we add more and more words, it'd be a little bit slower, but not much, I would say. So now for Zig, so we already have that compiled, so we can just run it. Yep, and then run it, and then boom, and you'll notice something interesting. So again, calculate the same number of words, which is great. That means it works, right? They're at least consistent with each other. But notice something very interesting is that Zig, you would imagine for something that, let's go back to their main files, something that, is emulating C and that you can manage memory and optimize a lot of stuff. You think maybe it would be a little more performant than Rust. But in this particular scenario, again, this is a very particular scenario, it'll change depending how we write this code and what we're doing. But notice it's a little bit slower. Again, this is milliseconds. This is not huge. This was still really fast. But notice it's slower than Rust. My best guess as to why is that the way this was written, and again, I had AI help me with this, so blame the AI. You can blame me as well, but blame the AI here. The way this was written was probably not in the most optimized way. So this is probably a much more naive way of writing Zig, and because of that, it's not taking into account all the little optimizations you can do to make this even faster, right? If you really wanted to get it to 12, for some reason I lost the time, but yeah, 12 milliseconds what it was. So if you wanted to really get it to 12 milliseconds, I have a feeling you could do that with Zig. You would just need to optimize this. But I will say, without really doing much optimization, Rust did pretty well, right? Like clearly all the stuff that's abstracted away is fairly well optimized. And so you can get some gains from that. Again, it's in the milliseconds. We're not going to, for most applications, that's not going to be a huge deal. But, for other applications, like let's say you do have some big application that has to read in a file, and let's say the file is really, really big, that might matter. If you don't want to do super detailed, kind of handwritten optimizations like maybe you want to do in Zig, if you're a Zig person. If you don't want to do that, Rust seems to have optimized it pretty well, I would say. So yeah, I think that's pretty much it in a nutshell. That's Zig and Rust with, I would say a somewhat surprising result, but again, it's a very specific use case, very specific app. So, what are your thoughts? Do you think this was a fair comparison? Do you think maybe Zig was treated unfairly? I didn't optimize it well enough. And do put in the comments how maybe we could get Zig to read this in 12 milliseconds or even faster if we optimize it. Because I am curious, because I'm pretty sure you could do it. I just don't know how, since I'm not a Zig expert. So leave that in the comments and any of your other thoughts on this video. And do hit that like and subscribe button. I really appreciate your support and watching these videos. So do hit that like and subscribe button if you want to see more of these live demos when I can do them. But I will also always have my mainline videos there every week. So thanks for watching, and I'll see you next time for more techie talk at the Techie Shop. If you like this video, watch this video here for more tech talk.